Yes.
Huh? And then let me try to share with you what we are supposed to cover today. Okay, so I hope everyone has got this book, physics textbook, senior one. And if you don't have it, please, you can go and reach out to the resources under notes and exercise, and you download the book. So today we are going to be looking at forces. So let's scroll very fast and we go to forces, page 62. Okay. So we are there. Chapter 4, effects of forces. Now, I would like to first know, first of all, what do you understand by the term force? What do you understand by the term force? What do you understand by the term force? Because in this chapter, you should be able to know what force is, what does this word mean, Newton, contact force, non-contact, resultant force, gravity, friction, molecular forces, cohesion, adhesion, surface tension, all those things. And also, excuse me, and also you should be able to appreciate the effect of force, balanced and unbalanced forces, understand the importance of friction,
Force.
understand the existence of friction of force of gravity, and distinguish between mass and weight. Also should be able to appreciate that weight of a body depends on the size of the force of gravity acting on it. And also understand cohesion and adhesion. They also explain the existence of surface tension and capillarity in terms of adhesion and cohesion. So at the end of this chapter, I should be able to know all these things and be able to explain them. Now, what do you understand by the term force? So we are going to look at effective forces. That's what we are going to look at. And we are going to start with force. What do you understand by the term force? I'm going to first ask questions, then later on we shall see. Have you ever experienced force, members?
Yes.
Yes, I would ask everyone to unmute. Phyllis, are you there? Unmute. Yes, and also Austin, also unmute. So what do you know about force? What comes to your mind if someone says, have you ever experienced force? And how did you experience this kind of force? Or have you ever exerted force on something, and what happened to that object? Yes, anyone with an answer, you just show up the hand and I can ask you. You can try, you can tell us. Is force this, okay, Austin, yes. Yes, Austin first. Austin. Austin, please. Okay, Austin, I think I cannot hear you. Let me ask Pav. Pav, can you go ahead?
I experienced force when I was pulling a rope.
So maybe let us first see those words you are saying. Pulling, isn't it? So the first thing is pulling. So there is pulling. What else?
I want to define the term force.
You want to define the term force straight away? Okay, go ahead. Go ahead. Yes. So what is force? Okay. Was it Pav wanted to define force?
No, no.
Okay. Yes, Phyllis. Yes, Phyllis. What do you understand by force?
A force is a push up. It's a push or pull of an object from one place to another.
Mhm. So they are saying that it's a push or pull of an object. So we have two words. We have pulling and also pushing. Do these words necessarily mean what force is? That for something for you to understand force, then there must be some pulling of the object, or for you to understand force, there must be pushing of the object. And when we say pushing, it means that the object, its position is going to change, isn't it? Position does what? Changes.
Yeah.
The position will change. Also pulling, it means that also the position will do what? Will change. So it means that if you apply force in form of pulling or pushing, we expect the change of position. Are we together? So I'm asking you now, do these two words, do they correctly mean what force is? The pulling or pushing? If they do, if we're agreeing that they do, let me ask you one question. Suppose I have a ball which is there, and that ball is not moving. It is just stationary on the ground. Is there a force on that body?
Yes.
Yes?
Yes.
It is not moving. It is just there stationary. The same way how you place a cup on the table, it is not moving. Is there a force on that body?
Yes.
Yes. There's a force. So later on, we shall see that there are some forces which do not need pushing, do not need what? Pulling. Are we together? They don't need pushing, they don't need pulling, but those forces are existing on an object. But what we know is that since we are looking at the effect of force, what it causes is the change in position, and the change in position is due to the pulling or the pull or the pushing. Are we together? So the force can one way or the other affect the state of an object, can change the state of an object, can change its position, can change its position, can change its shape and size, can also change position, shape, and size. So can change those two things. So you find that if you apply a force by pushing, for example, if you have a water can which is empty and you keep on squeezing it, pushing the air out of it, what will happen is that the shape is likely to change. The shape is likely to change. So as the shape changes, then it means that there is a certain kind of pushing that you have applied on that can to change its shape. And that kind of pushing is due to the force that you have applied. So we can say that force is, Phyllis, you say that force is the pushing. Force is
pulling of an
so is a push or pull of an object, is a push or pull of an object. Now we shall add on something that since we are looking at the effect of force, it means that this kind of push or pull will change the state of that object, will change its state. So I talked about the state. The state can be in terms of two things. It can be in terms of the position. So this is the state I'm talking about. Can be in terms of the position or can be in terms of the shape and size. So the force that you apply on an object, the push or pull of an object that changes its state of rest, that changes its state of So it can be state of rest. The word rest here is meaning position, is meaning position. So if I don't say position, what I can do is I can say rest, a state of rest or a state of position, a state of rest or uniform. You can have uniform motion in a straight line. Okay, in a straight line. So you should know that. Why are we saying in a straight line? Why are we talking about uniform motion in a straight line? It is because suppose an object is moving. Let's say it is moving. This is the ground, and the ball is moving. You have seen people playing soccer, and the ball is moving in that direction. Now it meets someone here, and someone kicks the ball back to this position. What does that one mean? It means that if the ball was moving in this direction in a straight line, then someone applies a force on that ball, and the ball will change the direction to another side. So it means that the force that is applied can also change the motion of the body that is moving in a straight line. Members, let me give you another scenario. Then you are going to give me another example where we have a body being changed from its uniform motion in a straight line. The other example is, suppose you are walking, you are moving and walking, and then someone knocks you. Someone knocks you by mistake. What will happen? Will you continue moving in the same direction, or you are likely to change the direction?
You are likely to change it.
Yes, we're likely to change that direction. Reason is that the force applied on you has made you to change the direction. Now, let me show you something here. Let me show you here. Do you know this game? It's called what? Is it called pool? Do you know pool? No, this one. Sorry, table pool. Do you know this game, members?
Yes.
You know this game, isn't it?
Yes.
If someone is playing pool and the ball is moving, what happens to that ball? If it hits another, it hits another one. And when it hits another one, what happens? The direction does what?
Changes.
The direction changes. So if there is a force that is applied on any of these games, come on, let us see this. Let us see how this thing happens. Let us see. Sorry, this is an advert. So if we have those balls there now, so when you see the ball that is moving, first of all, the ball that is moving in a straight line, when that person hits the ball, let me make it very slow so that we can see exactly what is going on. Very slow. So it means that when he hits the ball, what happens that at first the ball moves in a straight Moves in a straight line. I think here we don't have slow motion. We don't have slow motion here. Let me see this. When he hits the ball there, the ball moves in a straight line, but after hitting other balls, the ball changes the direction. So it means that even these other balls which are being hit, you see, when they keep on moving, they collide with one another, and when they collide with another, their direction also changes. Their direction changes. I want you to look at this one here. So you see the direction has changed like that, like that. So it means that there is always a force that is being applied, and that force that is applied will change the direction of that body that is moving. That's why we say that if the body is moving in a straight line and a force is applied on it, its direction is likely to change. So what is force? A force is a push. So the push was when someone pushed that ball using that stick. So it is a push or pull of an object. Is a push or pull of an object that changes its state of rest or uniform motion in a straight line. So that is the definition. And if you have not noted that down, it's high time that you note it down. Okay. Now let us go to the next thing. Members, are we there?
Yes.
Yes.
Let us, I'm going to ask you something here. I'm going to ask you something here. So you are seeing your book here. So they're telling you that you have already experienced a force in some way. Forces may play a role in everything that we do. It may be kicking a ball, turning a tap, or even by taking a bite. What shows that there is force? So in this chapter, you'll be able to learn different kinds of forces and how they affect the objects. So we have this scenario here, members. We have this scenario here. We are going to look at the meaning and the measurement of force. So I want you to look at these pictures very well. Can you identify what is being done in these cases? First of all, in picture number 1 here, what is going on in picture number 1?
A pool.
It is a what?
Pool.
It is a pool.
Pool.
It is a pool. So what is pulling? Is it the cart behind pulling the cows, or the cows pulling the cart?
The cows pulling the cart.
The cows pulling the cart. So in that case, we say that there is a pull, so there is a force that is applied on the force is applied on what? Is it on the cows or on the cart?
The cart.
The cart.
Cow.
The force is applied on the cow.
Cart.
No.
Okay, what is making the other one to move? Is it the cow making the cart to move, or the cart making the cows to move?
The cow making the cat to move.
Okay. Yeah, the cow is making the cart to move. So it means that now there is a push. Sorry, there is a pull that is applied on the cart by the cows so that the cart can start moving. Correct. Now I'm going to ask one by one to give me the answer. So let me go to Sean. What about where we have this kind of object here, an axe? What is happening?
It's pushing.
Is there anyone pushing the axe?
No.
So what is happening there?
Like this kind of fleeting.
Eh?
The axe is on the wood, but it's just standing, just pushing.
It is pushing.
Stationary.
It is stationary. So Sean, what is your conclusive answer? The axe is stationary, or the axe is pushing into the wood?
The axe is pushing into the wood.
Correct. The axe is being pushed into the wood. So the axe, maybe at time T, maybe before someone hit that axe into the wood, isn't it? And for us to have that axe into the wood, it is not just a matter of using some energy. Phyllis, have you ever used an axe?
No.
Phyllis has never used that. Let me ask you,
She has
Pav.
never.
Pav, do you know how an axe looks like?
Yes,
Have you ever used it? Really?
obviously.
Obviously,
We are working it at school.
at school.
Yes,
This kind of
Yeah, at
axe.
school there we normally use it. No,
at school.
in our villages.
In your villages, correct. Now, let me ask you, do you need to use, let me ask, do you see Phyllis has never used an axe? Do you know the reason why? Phyllis, can you tell us, what's the reason why you have never used an axe?
I don't think she knows.
Phyllis, is it because it is too light? It is something very easy to do? Phyllis, is it
Yes.
because it is not at home? Or, okay, you tell us in physics way.
At home.
It is at home, isn't it?
Yes.
So have you ever seen people using the axe? Do you see the kind of energy they use?
Yes.
Mhm.
The energy applied.
They put in a lot of effort.
They put a lot of effort, isn't it? So it means that
A lot of effort.
a lot of effort,
Yes.
so that the axe enters into the wood. So it means that you have to use a greater force for you to use the axe. So we are going to look at the examples showing the application of force. Examples showing the application of force. So far there we have seen two. We have seen one. There's a cow pulling a what? A car. A cat, isn't it? We have seen the second one. There is chopping. Is chopping, as you see, chopping wood using an axe, isn't it? Chopping wood using an axe. Then the other one is, can you give me any other?
Kicking a ball.
Kicking a ball. Kicking a ball. One more.
Cutting a tree.
Sorry?
Cutting a tree.
Cutting, using a what? Using a panga. Okay. Cutting a tree using a panga. Good. So all these examples really show the application of force in our daily life. Now, let us see how is force measured. In other words, let us see really what is the SI unit of force. SI unit of force. The SI unit of force. The SI unit of force. So members, you know that the SI unit of force is, you know that is
Newton.
is called a Newton. So it is called a Newton. So say the SI unit of force is a Newton. Is a Newton. It is a Newton. The SI unit of force is a Newton.
Is a Newton.
Correct. And then now,
Newton.
what's the symbol for a Newton?
Capital N.
Okay, symbol.
N.
Capital N.
Capital N.
So capital N. capital N. So the symbol is capital N, and the symbol is capital N. So if you write a Newton, so you write capital N as the symbol. All right. So let us proceed now. Now, okay. Now you should also ask yourself. You should also ask yourself. Number two, you should also ask yourself. How do we measure? How do we measure force? Force is measured using
A spring balance.
a spring balance. So members, in the picture here, we are having a spring balance. The one we are seeing here in picture 4.2, that is a spring.
As the symbol.
Yes, spring balance. Spring.
Unmute your speaker.
It's a spring balance. Okay, we have members who have come in. Let me greet Rosemary. Rosemary, good morning. Rosalind, she's called Rosalind. Good morning. Rosalind, good morning. Okay. Patricia, good morning.
Okay. But we can't hear you.
Patricia, good morning.
Good morning.
Okay. And Rosalind, good morning.
Good morning.
All right, good. So we are looking at the effect of forces, and we started some time back. We started something like 20 minutes back. So we have looked at what force is, and also we have looked at examples that show the application of forces, the SI unit of force. Now we have seen that a spring balance is the instrument that is used to measure force in newtons. I would request that if you have not yet prepared yourself, you mute, and then once you prepared, you can unmute later on. Okay, so let us proceed. We have seen that it is a spring balance that measures force. Now, this is just a picture here, but let me show you in reality what a spring balance looks like. In reality, what a spring balance looks like. So if we go here and we put spring balance. Okay, so this is how a spring balance. We can have this one here. This is how a spring balance looks like. This one here is a spring balance. We have it in the laboratory. It's there. When you come back, I'll be able to show it to you. I did not carry it, but this is a spring balance. It can be in this form. So it has, it measures in newtons. It measures in newtons. We have also another one here. Let me show you. There's this one. Have you ever seen this one, members?
Yes.
Yes. And I know, Pav, I know you have ever used this, isn't it?
Yes.
Yes. So this is also a spring balance. Inside there is a spring, and you connect to the body here, and then you can measure whatever you want to measure in newtons. So there are very many types of spring balances there. This is not a spring balance. This is a weighing scale. This one here. This is a weighing. This is a weighing scale, not a spring balance. This one, but there are others. For instance, those are spring balances. All right. Now, let us understand what a Newton is. If a spring balance measures force in newtons, so we are going to understand what really a Newton is. So what is a Newton? What is a Newton? What is a Newton? What is a Newton? Who can tell me? Who can tell me? Members, who can tell me? Pav, okay, let's start with Pav. What a Newton is.
A Newton is a force that gives a mass of 1 kilogram and an acceleration of 1 meters per square second.
I repeat that again.
A Newton is a force that gives a mass of 1 kilogram and an acceleration of 1 meters per square second.
Per square second, 1 meter per second. 1 meter per second squared. Are we together? Something like that. 1 meter per second. So, members, that is correct. Can we clap for Pav? That is correct. That is correct. That is you clap by correct. Anena knows how to clap. Yes, Sean, I've seen. Phyllis, let us. Very
Per square
good.
second.
Yes, per square seconds. Also, I've seen. So, Austin, you know how to clap. You go to reactions and then you clap from there. Okay, thank you very much. Very much. That is what we call a Newton. It is a force that gives a mass of 1 kilogram, an acceleration of 1 meter per second squared. Now, I'm going to help you to understand what this really means. So, first of all, let us assume that there is a box here. There is a box here standing. And we assume that this box has got mass. So the mass of this box is, the mass is equal to 1 kilogram. That is the box, and that is its mass of 1 kilogram. And we suppose that there is a force. We say that a force can be in form of a pull, or it can be in form of a push. So I can put here a force here. And now this one is going to be a pull, isn't it? This is a force, but it is in form of a what? A pull. Now this force is being applied on this box. And now this box is going to move that in every second, it's going to move 1 meter. In every second, it moves 1 meter. So it has an acceleration of 1 meter per second squared, like that. Or we write it like that. So the acceleration, you understand acceleration later on when we are looking at motion, but you should know that acceleration is the rate of change of velocity. And you understand all those things later on, but you should know that acceleration is the rate at which something is moving depending on its speed. So if it is moving 1 meter in every 1 meter, 1 meter per second squared, it is moving 1 meter in 1 second squared. So that is the acceleration. So it means that the force that will be applied on this thing, the force that will be applied on that body will be given by the mass of that body times the acceleration. Okay? So which is given mass equal, force is equal to M what? MA. Members, are we together? Are we together? Yes. So
Yes.
M stands for mass and A stands for acceleration. So if the force that is applied to only a mass of 1 kilogram, are we together? So the mass is 1 kilogram times the acceleration, which is also 1 meter per second squared. 1 meter per second squared. The acceleration is 1 meter per second squared. So it means that at the end, we shall have 1 kilogram times 1 meter per second. So 1 times 1 is 1, and kilogram times meters squared. So we have kilogram meters per second squared. Kilogram meters per second squared. So kilogram times meter squared, we get 1 kilogram meters per second squared. So that will be a force. So a force that gives a mass of 1 kilogram, are we together? An acceleration of also 1 meter per second squared is what we call a Newton. Is what we call a Newton. So it means that 1 Newton is equivalent to 1 kilogram times 1 meter per second squared. So a Newton is just a force that gives a mass of 1 kilogram and acceleration of 1 meter per second squared.